So the point of this problem is just to distinguish between population parameters and sampling distribution parameters. So I'm given here some information on a population. The population is 2012 Olympic marathon runners, the 85 finishers. Those are the Olympic marathon runners. They're their own population. They had a mean finishing time of 140.952 minutes and a standard deviation of about 8. A median was 139. So median is pretty close to the mean, so there's probably not much skewness in the data. And then what we want to do is find what's the standard error for sample sizes of 30. And think back to, we talked about this a week or two ago in chapter 3 on confidence intervals. Sample size matters. The bigger the sample size, the smaller the standard error is one of the things we were trying to get out of that. A sample size of 30 big? No, but it's bigger than 10, which is the previous problem had. So we should expect to see when you do this problem, you get a certain standard error from stat key. And here, since we've upped the sample size, we should get a smaller standard error. So how do we do this? Here, I'm not giving you the standard error like I did in other problems. We got to go find it. So I'm going to head over to stat key here. And if you're not on this problem, I'll put it in the chat. Get out early. Yes, we can always check out early. So let's see. Do I have the right data? No. And so my claim in that problem is the data lives here. And what did I say? Grab the Olympic Marathon 2nd edition minutes. Olympic Marathon 3rd edition, 2nd edition, 2012 data. So here's the population right there. I want to change the sample size to 30 to figure out what the standard error is going to be. And so that's for a sampling distribution. So if we took, samples of 30 over and over again, which we're going to do right here, this is basically applying this idea of the central limit theorem. And I'm going to do 6,000, 7,000. I think it's done there. 6,000 is good. So according to stat key, the spread of the sampling distribution, which means this is a whole bunch of samples of size 30 from this one right here, similar but different. So I have 3 different things going on: the population, the sample, and the distribution of samples of size 30. Standard error, which is the standard deviation here, is 1.188. So here, what's the standard deviation for the sample? Sample, that should say population. Typo. Fix that. Because again, the sample, I just ran 6,000, right? 6,000. And then the standard error, which is the spread of the sampling distribution, that was that 1.139? 1.188. 1.139. Should be okay. Will you get a little variation on this number here? Yeah, but the standard deviation here is the one from this given information at the top. So if I had a different sample size, I would have a different spread. So just double check that. If I reset this, keep it at 30, I should get about the same. This time it's 1.177, which is in the ballpark of the other one. If I drop that sample size down to say 10, then I should get a wider spread in the samples, more variation, because I have a smaller sample size. And my computer's struggling to calculate this. Yeah, so the sample size of 10, I get a standard error of about 2.4, which is a lot bigger than the sample size of 30. The higher the sample size, the smaller the spread here. Now here we have a limit. We can't choose the population, sorry, the sample size has to be less than the population. So the biggest sample size I could take is an 84. It's a little bitty population. So this was just a reminder that sample size matters. All right, so I think this is probably a good place to